So you remember what we discussed in the last class?
We were doing the numbers of the
Number of protons,
proton
electrons, and neutrons. So I told you that in atoms, number of proton is equal to number of electrons. And how to calculate the number of neutrons? By using the formula that mass number minus atomic number, it gives you number of protons. Now today we will learn a new topic of this chapter. You can see this slide. What are the similarities between these three versions of hydrogens? This is also hydrogen. This is also hydrogen. H means hydrogen. This is also hydrogen.
Yes.
Okay. So there are some similarities and there are some differences. Okay. Similarity is that all of these are hydrogens. What is the difference? Difference is that its mass number is 1. As I told you that the superscript is the mass number. And the subscript is your proton number or atomic number. Obviously, hydrogen atomic number is 1. As I told you that hydrogen is the first element in the periodic table. So its atomic number is 1. So you can see that proton number is same here also, in protium also, in deuterium also, and in tritium also. But their mass number is different. In protium it is 1, in deuterium it is 2, and in tritium it is 3. Okay, these are the names of hydrogen, different hydrogens. If its mass number is 1, it is called as protium. If its mass number is 2, it's called as deuterium. And if its mass number is 3, it is called as tritium. You can here see, if I ask you to calculate number of neutrons in protium, calculate and tell me the answer.
Number of protons in deuterium.
I'm asking number of neutrons in protium.
0.
Yes. And what is the number of neutrons in deuterium?
Neutrons, 1.
Yes. And what is the number of neutrons in tritium?
2.
Yes. So in the image you can see here there are 0 neutrons in the nucleus. You can see only 1 proton is there. In this nucleus you can see that there is only 1 neutron. Okay, as you have calculated here in deuterium. In tritium you have calculated 2 neutrons. You can see there are 2 neutrons. Okay. And electron is 1 only. Why electron is 1? Because its atomic number is 1. Its proton number is 1 and number of protons is equal to number of electrons. So you can see here that number of electrons is also 1 in all the 3 cases. Number of proton is also 1 in all the 3 cases. But number of neutrons is different. In protium it is 0, in deuterium it is 2, in tritium it is 3. So this leads to a new topic, that is your isotope. These are known as isotopes of hydrogen. What are isotopes? They are atoms of the same element. What is the same element here? Tell me.
The same element?
Yes. In this example, what is the element?
Or atoms?
No, in this example, what is the name of the element?
Oh, names.
Hydrogen, right?
Yeah, hydrogen.
Yes, so in all the 3 cases, we have hydrogen with different number of neutrons. Okay, so this is the definition of isotopes.
Yeah.
Isotopes are atoms of the same element with different number of neutrons. Is the definition clear?
Should I take this down?
Yes, I'm asking, is it clear what are isotopes?
Yeah.
Yes, so please write it down, the definition for isotopes.
Isotopes. Okay. Teacher, I had a question. Are there any like exams?
Are there any what?
Exams in these classes?
Yes. There are tests in the when I complete one or 2 chapters, then I'll take the test of previous chapter. And also I take oral
No,
test also.
I mean like like in a school to go to another grade, are there also exams for this class?
In Keddy,
Yeah, yeah.
there are no exams, like there are no scheduled exams, but there are tests which I will take on my on my wish. When I complete the chapter, then I will take your test in the class itself. I will show you a Word document and you have to write the answers. Then you have to send it to your respective WhatsApp group. They will send it to me. Okay.
Okay.
Are you going to school?
No.
So okay, may I ask why you are not going to your school?
Because like wait. Yeah, I'm done. So I don't go to a school because like it's hard for me to focus in
Okay.
class. That's why
Okay.
I am in Keddy. Sorry.
Yes. Okay.
Yeah.
No problem. Okay. So have you done writing?
Yeah.
Now write down the example which I have just told you, the example of isotopes for hydrogen. You can see number of neutrons are different here in these cases. Atoms of same element, it is completely matching the definition of isotope.
I should take down this, right?
Yes. Write down the examples for isotopes. You do not need to draw this, like draw these atomic structure. You just need to write down the names, like for the symbol and the name.
Yeah. I'm finished.
For isotopes. Okay, first example I have already told you for hydrogen. You can see here, this is chlorine, this is also chlorine. Number of neutrons in this case is 18. Number of neutrons in this case is 20. So isotopes are atoms of the same element, that is chlorine. Cl is chlorine. Okay? And which have different number of neutrons. You can see electron and proton are same, 17 and 17, but number of neutrons are different. So write down the second example for isotopes. It is chlorine. It is 35 chlorine and 37 chlorine. 35 is your mass number. 37 is your mass number. So there is a difference in mass number. Okay. In hydrogen also we have seen that there is a difference in mass number. See here. Here it is 1. Here it is 2 in deuterium, and in tritium it is 3. So isotopes have different mass number but same atomic number. See, in the chlorine also they have different mass number but same atomic number. Okay.
Yeah.
Write it down. And this is the atomic structure
Okay.
only. This is the atomic structure. Let me tell you this also. You have to fill electrons here. Okay, these are all electrons. So you have to fill 17 electrons in the atom. So how can you fill it? In the first shell, this is my first shell, this is second, this is third. In the first shell, which is also known as K shell. Okay, second shell is known as L, third shell is known as M, and fourth shell is known as N shell. So in the first shell, there is a maximum capacity of electrons that it can hold only 2 electrons. L shell can hold 8 electrons, M can hold 18, and N can hold 32. So these are your magic numbers in chemistry. But due to the octet rule, every element wants 8 electrons in their outermost shell. So we fill 8 electrons in M only, and the remaining electron we fill in N shell. So here you can see that in the first shell you have only 2 electrons. Okay, you cannot fill 3 electrons in the first shell. In the second shell you can fill 8 electrons. 2, 8. So its electronic configuration would be, this is known as electronic configuration. It would.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Would be electronic configuration of fluorine. So you should know its atomic number, that is 17. So you have to fill 17 electrons in the shell. In the first shell, 2 electrons. In the second shell, 8 electrons. Total become 8 plus 2 is 10. How many are left to fill 17? Tell me. 10 electrons are already filled. Now, in the third shell, how many electrons should I need to fill?
So the first shell. So the second shell has 8.
Yes, and third should have
one more.
1.
No, because 1, 2, 3, 4, 5, 6.
You have to fill 17.
17.
You have to fill 17 electrons. Okay, 2 plus 8 is done. That means 10 electrons are already filled. Now how many are left to complete it to 17?
How many are left? 17. 18.
7 electrons, right? Because now 2 plus 8 plus 7 is equal to 70. Okay?
Okay.
Yes, write it down.
2 plus 8 plus 7 equals to 7. Okay. Let me write it down.
Please let me know.
Yeah?
When you are done writing, please let me know. Because I can't see your video.
Yeah. Yeah, I'm done.
Now let us study the third example for the isotopes. Third example is carbon. Okay, one is this carbon. Atomic number is same. You can see atomic number is, what is atomic number in these cases? Tell me.
Atomic number in which cases?
In all these three cases, what is the atomic number?
First one is 12.
Atomic number.
5, 6, 6. Atomic number. I don't know, teacher.
Atomic number I told you, na, this subscript is known as your atomic number.
Subscript is atomic number, right? It
And
is
this
6.
is your mass number. So I told you this in the very first class. This is a representation. You should know at least these things. That the superscript is mass number and the subscript is atomic number. So please make it very clear, because if you do not understand this, then you will not going to learn the further topic. So it is very simple. The number which is coming below the element, it is atomic number. Number which is coming above, it is mass number. Now you can easily calculate the number of proton, electron and neutron. I already told you how to calculate number of protons, electrons and neutrons. So here also you can see there are 6 neutrons. Here there are 7 neutrons. There are 8 neutrons. So element is same. What is the name of the element? Carbon. Element is same, but number of neutrons are different. Okay. So write down this example also. This is the third example for isotope. the atomic number or proton number, it is one and the same thing. Atomic number is also called as proton number. So don't get confused. Make a star mark or important note and write it down. Atomic number or proton number, it is same. It is the subscript basically, which is written below the element.
Yeah. Okay, done.
So please solve this question. You have to answer what should come in the first blank, what should come in the second blank, and what should come in the third blank. I'm giving you 1 minute.
Yeah.
Think and answer. So please look at your notes, think and then answer. So now this is enough time. Isotopes are different atoms of the same dash.
Same isotopes are the different forms
Same
of the
what?
same protons.
No.
No, sorry.
Look at the definition. I have told you to write the definition of isotopes, right? Have you written it in your copy?
Yeah.
So look at the definition for isotopes from your notebook and tell me.
The definition we just wrote before this, right?
Yes.
Like I don't get the answer, like what it says.
No, it's okay. Answer is hidden in your definition only. So tell me the definition of isotopes which you have written. Look at your notes. By looking, you can easily tell.
Electron.
Read it aloud.
Isotopes are atoms of the same element with
Yes,
different
answer is
numbers of
again.
neutrons.
Again read.
Isotopes are atoms of the same element.
Stop. Now stop. Now what should be the answer here? You have just tell me the answer. Isotopes are
Element.
atoms. Yes. Isotopes are different forms of the same element with same number of.
Wait, I forgot to write the heading. That's why I didn't find it.
Why you forgot to write down the heading? Heading is important. Without heading, how can you study what you are studying? Okay, no worries. So tell me with the same number of. Read the definition again.
Neutrons.
Hmm?
With the same number of neutrons.
Neutrons are same in isotopes. Are you sure?
No, sorry. They're different.
Yes, so different number of neutrons. In the third blank, neutrons should come. What should come in the second blank?
Elements.
Element comes in
Sorry,
the first blank.
Element comes in the first blank. Wait.
Look at the definition now. Now you can easily find the answer.
The same element. Neutrons are a third. Then that proton.
Protons are same, okay? For hydrogen it is 1, for chlorine it is 17 in both the cases, and in carbon isotopes it is 6. The
Yeah.
protons are same and neutrons are. Now some isotopes are radioactive. Some isotopes are radioactive. What are radioactive? For example, you have studied 3 examples: carbon 12, carbon 13, and carbon 14. So this is radioactive. Radioactive means that its nucleus is unstable. Radioactive means that its nucleus is unstable. After some time, this atom breaks down naturally or it decays. It gives out radiation in the form of rays and particles. It gives us large amount of energy. Okay, so there are various other elements which act as radioactive isotopes, which are also known as radioisotopes. They decay naturally or by artificially. They decay. Decay means they break down. Their nucleus will break down. It will give you large amount of radiation. But these two, carbon 12 and carbon 13, their nuclei is stable, so they do not decay. So they are not radioactive. Okay, so write down this slide
Yeah.
that some isotopes are radioactive. Example is carbon 14. Carbon 14 is radioactive. Radioactive means why it decays? Because its nucleus is unstable. Why it's unstable? Because it have higher number of neutrons. How many? It have 8 neutrons, which are very high. Okay, so write down this slide.
Yeah.